solve the system by substitution. So again, step number one, we want to go ahead and find a variable that's been isolated, and I notice that y is isolated in the top equation. So I will take this quantity of negative 2x minus 7 and I will substitute it in for y in the second equation. So there's step number one. Let's move over to, let's use blue. This equation, I'm just going to rewrite it. So I have 4x plus 3. And now I'm going to give myself a set of parentheses, and into the parentheses where the y used to be, in its place, I will put negative 2x minus 7 because we said negative 2x minus 7 equals y. So going in there. And finish off the equation is equal to negative 3. After that, so this is going to be step number 2. Now we're going to find out what x is equal to, but I'm going to distribute this 3 over here to the negative 2x, and then this 3 will also be distributed to negative 7. So 4x minus 6x minus 21 is equal to negative 3. I'll combine 4x and negative 6x to result in negative 2x minus 21 equals negative 3. Add 21 on each side. And let's see, cancels. I have negative 2x is equal to, that's going to give me positive 18. And then I'll divide by negative 2 on each side. And I have x equals negative 9. After that, now I'm going to go ahead and take that value of x, which is negative 9, and I will substitute that into the top equation just because it looks like an easier equation. But again, when you get to this last step where you're finding the second variable, it's whatever you want, top or bottom. So now I have negative 2, parentheses, in goes negative 9, minus 7 is equal to y. We always multiply before we would subtract. So negative 2 times negative 9 is 18 minus 7 is equal to y, and then 18 minus 7 is 11 is equal to y. So now we actually have our solution. X comes first, so there's negative 9 comma 11. And then just like I did in the last video, you can go ahead and fast forward to the next example that I'm going to give you that has x isolated. But if you want a great test-taking strategy, watch how I will substitute negative 9 for x in both equations, and then I'll substitute 11 in for y in both equations. So I have negative 2 x minus 7 equals y. There's the equation on the top. On the bottom, I have 4x plus 3y equals negative 3. And again, I'm going to write negative 2. In for x goes negative 9. Minus 7 is equal to 11. Then I have 4. In goes negative 9 for x plus 3. In goes 11 for y is equal to a negative 3. And then we evaluate. So in this one, I would have to multiply before I subtract. So that's going to be 18 minus 7 should be equal to 11. And 18 minus 7 is equal to 11. 11 equals 11. So that's true. That's good. That works there. I'm going to multiply here and multiply here because we multiply before we add. So that's negative 36 plus 33 should be equal to a negative 3. And then negative 36 plus 3, that's negative 3 equals negative 3, which again is true. Because it works into both, we're guaranteed that we have it. All right, next example we're going to do the same thing, but instead of having y isolated, we actually have x isolated instead. So since x is isolated in the second equation, I'm going to start right there. And I will substitute 2y minus 3 in for x right here. So that's my step number 1. Step number 2 is I'm going to rewrite this equation over here. Where the x is, I will substitute 2y minus 3 minus y equals 21. And that's step number 2. Now I'll distribute the 5 here. Just be aware if that was a negative out there, you'd have to distribute the negative with it. A common mistake I keep seeing is that when you distribute the negative, if that was a negative 5, a lot of people forget that it's a negative 5 and they distribute a positive 5. Common mistake, so watch out for it. So 5 times 2y is 10y, and then 5 distributed to negative 3 is negative 15 minus y, or you can make that negative 1y, whichever. I'm going to combine 10y and negative 1y. That's 9y minus 15 equals 21. And then we'll add 15 on each side. Cancels. 9y is equal to, let's see, that's going to give me 36. And then we'll divide by 9 on each side. So y is equal to 4. Now that I'm done with step number 2, step number 3 is going to state that we're going to take 4, and I'll substitute that into either equation, but clearly this is going to be the easier one because x is already isolated. So I would have x is now equal to 2 parentheses 4 minus 3. We multiply first, so I've got x is equal to 8 minus 3. And my apologies for the horrible x. And then 8 minus 3 is 5. So my solution is going to be 5 comma 4. And again, if you want a great test taking strategy, I'm going to substitute 5 for x in both and then 4 for y in both of them. And again, you could go ahead and fast forward or stop the video. Just watch and view as much as you think you need to so that you get this. But again, this is a great testing strategy. So I've got 5x minus y is equal to 21. And then I have x is equal to 2y minus 3. I'm going to substitute 5 for x. I've got 5 times 5 minus 4. Now notice when I put in that 4 for y, that's going to change to negative 4 is equal to 21. And then I have 5 for x is equal to 2. In goes 4 for y minus 3. The one on the left, I'm going to have to multiply 5 times 5 before I subtract 4. So that's going to give me 25 minus 4 is equal to 21. And then 25 minus 4 is actually 21, and 21 does equal to 21. That's true. 5 is equal to multiply before we subtract. So 2 times 4 is 8 minus 3, and 5 is equal to 5, and that is also true. 2 trues in a system means that it works, so 5 comma 4. And there you have it. Hopefully you found out a quick review of this and the test taking strategies to substitute the ordered pair into both equations. 2 true statements guarantees you got it right. Thank you for viewing.